The good news about an independent samples t-test is that you already know how to do this procedure. If you've been watching these videos in sequence, you might remember that back when I was showing you how to do a one sample t-test, we used this same procedure. The data are just set up a little differently, that's all. But you already know how to point and click and what the output looks like and how to interpret it. So this will be a little bit of review. What we have here in the data set are two groups of separate individuals. Now, our first group is represented here in columns A and B, and there are 30 of them right there, and each of them has a unique ID in this ID underbar interview column, column A. And then in column B, for each of those 30, we have the rating that they gave a political candidate, the approval rating they gave a political candidate after watching that candidate be interviewed by a journalist. And then over here in columns C and D, we have 30 more individuals, see, each with his or her own unique ID in the ID underbar debate column. And then in the rating underbar debate column, we have their approval rating of the same candidate, but after watching the candidate perform in a televised debate. So to sum up, we have two groups of 30 people, all rating the same candidate using the same approval scale, but one group rating the candidate after seeing the candidate interviewed by a journalist, and another group rating the candidate after seeing the candidate perform in a televised debate. So what we're going to do is we're going to use a two-sample t-test to find the average rating interview among this group of subjects, and then find the average rating among this group of subjects, find out whether those two averages are different, and if they are different, find out whether the difference between those averages is large enough to suggest that the difference occurred for a non-random reason. All right, so here we go. You know by now that to get this started, you click on the Data tab, and then you click on the Data Analysis button, and you need to choose the t-test two-sample assuming unequal variances. It's this one right here. T-test two-sample assuming unequal variances. Whoops, kind of jumped around there. That's the one you want. Now highlight that and click OK. All right, and you see the now familiar dialog box that you just need to fill in. The variable 1 range would be this column right here, column B, the rating interview of those, the rating of those who saw the candidate interviewed. Just highlight that, clicking and dragging, and then click the red X. The other input range would be the ratings given by those who saw the candidate perform in the televised debate. Again, just clicking and dragging to highlight those, including the column heading, notice that, and then clicking on the red X. The hypothesized mean difference is, as always, 0, right? Check the labels box there. Alpha 0.05, that's fine. And as you know by now, I prefer to have the output in the same spreadsheet page as the data, so I'm going to click Output Range there, then come over here and click the little spreadsheet icon and tell Excel where I want the output to go. I'm going to put it right here in cell F1. Right? Okay, quick last check. Everything looks fine. I'm going to click OK. And there's my output. Again, it's all squished up. You've seen me do this before. I'm going to just expand these columns. There we go. And scooting over a little bit, we have the a little bit more. There. We have the average rating among those who saw the candidate interviewed by the journalist as 5.4, about mid-range on the 1 to 10 approval scale. And then among those who saw the candidate perform in the debate, the rating's about 6.2, a little bit higher, about 1 point, a little less than 1 point on the approval scale. All right, so there's a difference in the averages, but is that difference large enough to suggest that there's some non-random reason for the difference? And the answer is right down here in the P2 tail box. It turns out that yes, it is large enough. The p-value we see here is 0.02. It's not as small as some of the p-values we saw in the earlier examples where we actually went into scientific notation, in one case with 50-some zeros before we got to a non-zero number to the right of the decimal point. But it's still a small number. It's 0.05 or less, which means that there's less than a 5% chance that this the difference between these two averages showed up due to a purely random reason. Well, if there's so little probability that the difference showed up for a random reason, then the next likeliest conclusion is that they showed up for a non-random reason, that there's some systematic reason why this average is higher than this average. And given how we set up the experiment here, the reason is fairly obvious. It probably is something having to do with watching the candidate perform in a televised debate versus watching the candidate be interviewed by a journalist. All right, so that's how to do and interpret a two-sample independent samples t-test in Microsoft Excel.